In this video, we're going to talk about the from and the join statements in LINQ, and we're going to look at how to use those to retrieve both a flattened set of information as well as a hierarchical graph of objects that have established relationships or relationships that haven't already been pre-established. We'll talk about that in just a moment. And we're also going to look at how we might create what basically is an inner join as well as an outer join if we were talking about this in terms of transx SQL, the equivalent to that in LINQ. Also, we're going to look at how to do this, just like we have in the past, with both the query syntax and the method syntax. So we've got a lot of ground to cover here. So first off, we never really talked about the from part of our LINQ queries. Up to this point, we've just kind of glossed over that. What is that really? When we look at a LINQ query that starts with from O in orders, for example, what's the significance of that O in part? Well, the O part gives us the ability to reference a single item in the sequence so that we can work with reference to the properties of that item or the item itself if it's a simple type. So we're basically defining a for each O in orders so that we can work with each item and determine whether it should be pulled off into the query results. Except that we're not doing a for each. Internally, LINQ doesn't commit to a looping implementation. Each flavor of LINQ will work a little bit differently, but typically it's more analogous to an XPath or a regular expression, if you're familiar with those. All right. Also in the previous video, we saw how we were able to navigate through the hierarchy of orders to order items, and we're going to continue to do something like that in this video. So we had something like this: from O in orders, from OI in O.order items. What's going on there? We kind of glossed over it a little bit. That's basically working with an item in a sequence of items in a sequence of items through the use of an established relationship. So for all of our orders, consider a single order and then consider all of that order items. And so the OI part gives us each individual order item within an order within a sequence of orders. Okay. But what if you don't already have an established relationship between two sequences, and yet you need to join those two disparate pieces of information? Well, that's when you would use a join in LINQ. Okay, so let me just stop right here for one quick second. If your goal is to use LINQ to entities eventually, then you're probably not going to create a lot of joins. You're probably going to use the formal relationships that have already been set up, already been defined in the object relationship model, okay, the ORM. Joins in LINQ seem better suited for two disparate collections, unrelated collections of stuff that were never intended to be related together. Now, since 99% of my LINQ work, whenever I work with LINQ, is using LINQ to entities or LINQ to SQL or something along those lines, I haven't written many joins. Haven't needed to. And if I did, I probably would have to struggle with it quite a bit. So if it's any encouragement, some parts of LINQ are going to come natural to you. They're going to be easy and obvious. Some parts are going to be a little bit more difficult, and you might have to, put your thinking cap on for a little bit. This is definitely one of those topics for me personally, because I just don't write them very often. But anyway, let's take a look at this example that I've set up, and maybe we can work through this together and learn a little bit about how to make all this work. First of all, it has the typical setup. We have our setup orders method here that we've had in the previous videos. We have our order class. Every order has a list of order items. Every order has an association with two addresses, a home and a work or a shipping address or something along those lines. Okay, you can see that I've added a new class called product. Now here's the interesting little tidbit of information about that we need to keep in mind. This class has a field called product name. The order item class also has a product name. These two are not related together in any way at this moment. They just happen to have a field of information that share the same name, product name. They could have a different name for the exact same field of information, but in this case they don't. Now what I've done here at the very beginning is I've created a list of products, and I went about using some of that fancy new syntax that we talked about earlier in day 9 to create a list of products, and initialized about 4 products and added them to the list, each with a product name, each with a price. Now I just happen to cook the books, if you will. I just happened to ensure that these names matched some of the product names described in our order item definitions here in the setup order method. All right, now you can see where I'm going with this. I want to take this list and join it together with this list when all they have in common is this product name. There's no formal relationship between the two. In other words, the order item has no knowledge of an instance of a product, nor does product have any knowledge of an instance of order item. They're two completely separate notions in my code so far. So let's do a simple join statement to marry these two worlds together, to bring them together, and to print out. Let's see what we're going to do here. It looks like we're going to create a new anonymous type called summary report. And it's anonymous because you can see here when we project it out, we're not naming a type. Okay, so that's part 1. Then what we're going to do is do our join from order to order items. Then what we're going to do, and we already know that this relationship is established. We have that relationship between order and order items through the use of this order items property right here. Okay, so that part makes sense. Now the new part here is the join part. Here we're going to use this join keyword. We're going to join P in products. And this looks a lot like how you would do a join and inner join and transact equal. Join P in products on I product name equals P dot product name. Notice the equals keyword as well. And then what we'll do is start selecting out some of the fields of information pulled from order, order item, and product into a new anonymous type that will then roll through and print to the console window. In fact, I probably should do this. Let's see how well this works. Okay, and it seems to work. And so we can see here that we have a new type, product name equals food bar, item price, order ID, and quantity. So for every order, and you can see some orders are repeated, like here is order 9009, and here's 9009 again, here's 910, 910, 9010, 9011, 9011, and so on. We're going to grab out how many of a particular product was ordered in that order and the order price. And we pull that from all 3 lists of information that we've got available to us now. So that's how we create. It looks a little complex, but that's actually kind of a simple join. Okay. Now the only problem with this is that it's flattened, meaning that our type here, there's no notion of whether now this type has an order, has order items, which has a relationship to products. It's all just one new type. It's in a new anonymous type, a list of them that we're working with here. So that works in some cases, but what if we wanted to do something a bit more interesting? Well, what if we wanted to get a list of products and which order items contain that product as well as their quantity? So let's do this. It's a little bit more advanced, but hopefully we can talk our way through it. All right. Let's run this to make sure it works first before we talk about it. Okay, so you can see already there's some hierarchy to this. A product, foobar. Which orders or order items have ordered foobar, and what was the quantity of that order item for that given order? All right, so that's a little bit more advanced, right? But it's nice, it's hierarchical. this is the beginnings of maybe what becomes a cool report to let us know reorder quantities or how well certain items are selling in relation to other items. Let's look at how we pulled this off. First of all, you can see that I created an order list. So again, we've joined order lists and order items, and we get a flattened list of order items. Now we're going to use that in our next part here. So from P in products, join M in my order list, the flattened list of order items. Join those two on P.product_name equals M.product_name. Okay, so we saw this a little bit earlier here, right there, right? And we use this new keyword into my order items. Select new P.product_name my order items. Okay, so what in the world is going on there? Using that keyword into allows you to shape the data into a related hierarchy, even if that hierarchy doesn't formally exist through your class design. So the result of this join is going to be saved into my order items. And then what we're going to do is create a new anonymous type that starts with the given product and then associates with it all of the individual order items that are associated with that given product. Okay? And then we're going to grab it out, product sold, and now we can start looping through. So we do a for each within a for each. So this actually provides some clues onto what is going on here. First of all, we start with products in product sold. So for every P, which is a product name, in product sold, give me the product name. And then within P.myOrderItem, so you can see P.product_name is one property, P.myOrderItems is the next property in product sold. So for each item in my order items, then print out that order item's ID and the quantity ordered. Okay. So again, a little bit more difficult, but essentially the key notion here is this keyword into, pulling that list of items, that join that we've created into this my order items, and that gives us access to each of the individual order items that are associated with a given product. Okay, and we could kind of flip this into its head and accomplish a similar sort of thing, going the other direction if we wanted to, but I'll leave that for you as an exercise. Okay, so let's move over to the method syntax. All right, the challenge here is that the method syntax is a little bit hard to understand sometimes. So for example, let's do something like this. Okay, so let me see if I can explain this. It's a little tricky for me even to talk about this, quite honestly. Consequently, this is not going to work. It was my first attempt at trying to build this this statement here, all of this, using the method syntax. And I'm going to tell you where I went wrong, I think, with it. First of all, you can see that we start off with a select mini, which, if you remember from the previous video, allows you to flatten out a hierarchy of items. So where we may have every order has one or more order items, what if we wanted a whole list of just order items, irrespective of which order that they're associated with? The select mini would flatten that list out so we could work with it. So what gets returned from this is a list of an enumerable list of order items. Then we chain together a join, and a join is kind of weird because it's got a couple of parts to it. Notice first of all that we have some strange nomenclature here. If we take a look at the join, you can see that there are essentially two, or rather four input parameters here. There's four types that are required to make this work. Notice first of all that the input parameter I enumerable of type product will be the inner part of the join, and that we'll need next a func of order item and string as the outer key selector, and then a func of product string as the inner key selector, and then func order item product order item as the result selector. Whew, That's a lot of work. This is why it's easier to work with the query syntax in this particular case. But if I might pick it all apart, just see what it's saying here. In the first case here, the first part of this is a list of an enumerable list of products or individual product. So that's where product comes from, and we define that way up here. All right, so that's the first thing join needs. Think of it as one side of the table join, okay? Then it needs the outer key selector. So it's going to, what we're trying to do is for every order item, join it with a product. Give me the list of products first. Tell me what the first side of the relationship should be that I should evaluate. Give me the name or how I should evaluate the other side of the join statement. Okay, and then finally give me the result here, how I should join each of these two together. So given an order item and given a product, return to me an order item for that product based on this join criteria, this inner and outer selector criteria. Okay, again, I'm not exactly sure if I can adequately explain how it works. So what I would have hoped to have seen is the same thing as what we got from this example. But when I ran it, here's what I got instead. I got just the type names. Order item, order item, order item. Well, what went wrong? The fundamental problem is that it's not doing the join at the right time. I basically can't get to the O, the order itself, and so it throws everything off kilter a little bit. So I took another pass at it after staring at it for quite some time, and you'll see this looks a lot more complicated, but it retrieves the results that we actually want. In this case, we're still working with flattening a list of order items into order list. In the select many, however, inside of that body of that lambda expression, I am doing some projection inside. So it's going to look very similar, but inside, with regards to the fact that I'm flattening out this so that we're only looking at order items, but inside of that lambda, I'm doing a join. Instead of tacking it on to the end of the previous operation, I'm embedding it inside of the operation because that's where the join has to happen. These are happening at two different points in time, and so they're never really connected together. Here, I'm embedding it inside of it so that the join happens within the context of order. I know I'm not explaining that very well, I apologize, but you can see the process that I had to go through to get those results. So this is the same. This is all the same. Whoops. The parts that's different is this right here. Here, instead of just returning an instance of order item, I'm projecting into a new object that includes the order ID. And you can see I can get to it now because it's within the same lambda expression. It's being passed in. All right. So at any rate, if we run this, we get the same results that we got previously. Okay, so a long way to travel to get to the same results. So in this example, the select many part allows you to flatten a sequence of sequences. Let's take a look at another example that will allow you to do exactly what the join does, but it groups the resulting I enumerable. This is what gives us that hierarchical navigation from products to order items containing that product. So I'm just going to paste this in. And here we're using group join. Again, its value is that it gives us that hierarchical navigation. It groups together the resulting I enumerable into a hierarchy. So for every product, give me a hierarchy, group join, whatever's returned from the lambdas. So inside the lambdas then, I'm doing another select many to flatten out order items, just like we talked about previously. Here we're going to do all of that work that we've done previously with the selectors and so forth. So here on the left side of the relationship, we have product name. On the right side of the relationship, we have product name associated with each order item. And then the resulting output should be a new type called product name, or that contains product name and a list of my order items. Okay, and then we're going to do the same looping that we did previously when we worked on this example here. Let's run the example. Okay, so we got that nice hierarchy. All right, so this was quite a bit more complicated. There's no way in the world I would expect you to understand it. Heck, I don't know that I completely understand it. My takeaway from this is that when it comes to joins, I'm going to avoid them if I can. And the second takeaway is when it comes to joins, I'm going to rely mainly on established relationships between objects unless it's absolutely necessary that I have to do something like this. I wanted you to be exposed to it to show you that it is possible. And I wanted you to be exposed to it because when it comes up, the query syntax might be easier to understand and use practically than the method syntax in this particular case. So again, showing you the difference between the two. And in this case, I'd have to say that while I prefer the method syntax most of the time, in this case, the query syntax wins out. Okay, so that wraps up the from and the join statements. In the next video, we're going to look at quantifiers. And then after that, we're off to the exercises. So we'll see you in the next video. Thank you.